Right. Okay. I think we'll make a start. I'm looking at the list of attendees. I think we've got pretty well everybody now who's registered. So, yeah. So, good afternoon, everyone. Welcome to this is the ninth special interest group session that we've run so far. My name's Graham Charlesworth, for those who've not met me, and I'm the MD for Pureinsights. Yeah. So we've had a really good series of events over the years. This particular one, Pureinsights have been asked to present at. We presented at the very first one, and we've been asked to come back and really just talk a little bit about, RAG and our experiences with it today, working with organizations around the world. Some of them are on this, in this session now. And to do with, designing, building new applications and improving existing ones. And it's a incredibly topical subject, as I'm sure a lot of you are aware of. So that's really the subject for this particular session. Phil Lewis, our Chief Technology Officer, who I know a lot of you know very well, he's going to go first, and we'll be talking about our sort of observations, the challenges we're experiencing day to day, and also, separating some of the fact from fiction, because there is a lot of fiction out there around this subject. And then Phil will be followed by Matt, who's one of our senior architects, who'll be talking about kind of optimizing RAG systems and measuring the accuracy of them and so on and so forth. So that's really the lineup for the day. And with that, I'm going to hand over to Phil. Thank you.
Thanks. Great. Can everybody hear me okay?
Yep, loud and clear, Phil.
Perfect. Great. All right, we'll jump straight in, and we're going to take a little bit of a journey with regard to RAG and large language models and how they interact with each other, and really how they're changing today. So first of all, we kind of all understand what RAG is, and RAG is kind of this ability for an LLM to be injected with ground truths, normally obtained from documents, and then to intelligently kind of walk through those documents and answer any questions you might have of them. And the kind of hexagons up there on the top left-hand side is where we were probably a couple of years ago. We only had a couple of versions of RAG. We had simple naive RAG, basic grounded questions and answers, and we also had simple RAG with history. So this is typically used in a chatbot, so you can understand the end user's full journey within the RAG system. But we're also playing devil's advocate, if you like, or having problems with certain parts of the RAG architecture. First of all, for any given question, we need to find the right set of documents that can answer that question. When we did find those pieces of content, could we squeeze them into the window? Because all LLM context sizes are limited, at least to some degree. They've been expanding quite significantly over the years, but it still is a problem today, especially when you've got lots and lots of content potentially contributing to the answer. And then the response is also limited to some degree. Can we convey everything we need to in the output window from the RAG outputs? And sometimes it comes as a surprise that when you ask a question, sometimes a full-blown result set with 1,000 documents in it is not possible to fit into the output window. So there's lots of things that you need to do in order to get around these kinds of limitations. So basic grounded or simple naive RAG, simple RAG with history is actually spawned into a lot more different versions of RAG over the last year or so. And I'm not going to go through this list. The list is all available to read in Google, and we'll be very happy to send you links to this information. But there are some key things going on within this RAG. Most of the key things that are happening within these different variations of RAG are to overcome problems with the simple naive RAG systems. So all the way through adaptive RAG, branched RAG, corrective RAG, even graph RAG. There are all kinds of things which are trying to overcome the problems that we see with simple naive RAG. And we'll get into this in a bit more depth throughout the presentation, but I just wanted to give you a little spoiler. And it's really interesting, and I'll give you some evidence for this in just a second, but some of these architectures are going into the LLM itself. Okay, and really between those two dotted lines, we're starting to see evidence in the newest LLMs that this is becoming less of an issue going forward. It's still an issue now, but when these new LLMs hit the streets, we'll be able to instantly clear the decks, if you like, from these kinds of applications that we're kind of building at the moment. So let's get into the meat of this. Let's talk a little bit about the LLMs themselves and where they've come from. This is kind of where we were about a year ago. You know, GPT-4 was out and about, Palm 2, Claude 2, Llama 2, they were all kind of the large language models of choice. And there was some real good deep cleverness going on within these large language models. But we started to play with them and we needed to make improvements. And where we are today, almost a year later, is we have a different set of models, mostly. That are prevalent within the industry. So you can see a lot of models here from Google, Anthropic, Amazon, obviously the incumbent OpenAI is there as well, and a lot of other players kind of getting into the mix as well. But there's this big ominous thing on the right-hand side, which is Next, which was about 6 months ago earmarked for 2024. It's now probably going to be 2025 before we see some of these things. So what are these things? There's a whole bunch of new large language models coming downstream from Amazon and OpenAI, of course, from Meta, from Google, and some new players also entering into the mix, most notably X, Elon Musk's latest company. So lots and lots of things all hitting the streets round about the same time. These are just projections. We don't really know the exact dates that these things are going to hit the streets. Some say some of them will appear before Christmas. Most say they will appear after Christmas. One of the most notable additions to the large language model space in recent months was OpenAI's O1 model, and this was released midway through September and has some very, very interesting capabilities that none of the other large language models to date have been able to achieve. To give you an idea where we're heading, OpenAI is on the cusp of launching GPT-5. To give you a scale of what this thing looks like, GPT-3 had about 175 billion parameters. GPT-4 has about almost 2 trillion parameters, and GPT-5, we think, is going to have about 52 trillion parameters, right? So this is a huge beast in terms of its capabilities. It's about 300 times bigger than GPT-3. In total size. If you look at the amount of CPU time that went into training the model, for GPT-3, it was about 405 years of CPU time. GPT-4, it's about 6,500 years of CPU time. And GPT-5, about 16,000 years of GPU time. So a significant kind of investment in building these models. If you look at Grok 3, Grok 3 is currently targeted at around about 32,000 years of CPU time to train it. So yeah, we're all eagerly awaiting this model just to see what we can get from it. And the industry is broadly positive about this thing, making bold claims about what this model can do, where it will take us, and how we might interact with it going forward. But seriously, how clever are these things really? And there is a test now. There hasn't always been a test, but this test is called the GPQA test. What it does essentially is it poses 448 incredibly high quality multiple choice questions in the sciences, mostly biology, physics and chemistry, and they are extremely difficult questions. And this is kind of the new benchmark for working out how well a large language model can understand content and answer questions based on that content. Typically, if a domain expert, a real physical human, takes part in the same test, they will achieve around about 65% accuracy, on average. And that's in their chosen subject, right? So if they are a PhD level person in chemistry or biology, they'll achieve about 65% accuracy across all of those questions. So a fairly, good test of the capabilities of the large language models. If you're a non-expert PhD, so you've got a PhD, but not in chemistry, it's in one of the other domains, or even others beyond these, then the expected pass rate is about 34% on average. Okay, and this is a really stringent test. And the other key thing to notice is that Google is allowed, full unrestricted access to Google is allowed when taking part in these tests. So you have access to the full world of knowledge, but you need to know how to ask the right questions, how to speed read to get the right answers back as quickly as possible, and then formulate your thoughts from there. So it's a pretty humdinger of a test that they thought up for these things. And when we plot these large language models against their kind of pass rate, if you like, their exam rate, then we can see that most models are down here in the kind of the PhD general area. They're somewhere between, I don't know, 30% and 50% in pass marks. So we can see GPT-4o, which is one of the latest models from OpenAI, has achieved the best in this kind of zone. But we can start to see some of these new models actually achieving better pass rates than even domain experts. Okay, so this is your domain expert here, expected pass rate 65%, and the new OpenAI model has achieved a 78.3 pass rate with these tests. So it's getting very, very exciting and very, very interesting. However, there is also this counter-rotating opinion of large language models. You know, those are the raw tests and directly comparing those tests against humans. But what we can see here is this counter-rotating kind of set of opinions that we're also seeing, right? So AI is dumber than a cat. Bigger AI chatbots more inclined to spew nonsense, and people don't realize it. And this is really interesting. So here we did a little bit of a test. This is the GPT-4o model, as we can see, and it's kind of here within the chart. And we've told it that it's an excellent calculator. We've given it a list of numbers, and we've said just add them up. So we'll ask it to add the numbers above. We'll run that test, and it comes up with a number, and a very specific number, a very definitive number. And what I'm going to do now is just delete that answer and ask it to do it again. And a completely different number. Okay, 7,300 this time. I'll delete that response and ask it to do it again. And again, a completely different number. So yeah, how is this possible? How can an AI-based system, a large language model, be regarded as better than a PhD 1 second? And just by giving it a really simple task to add up some numbers, can it fail so miserably on those types of tasks? And this might be one of the reasons why lots of organizations who are investing time in these large language models and generative AI in general are not actually necessarily pushing all of their general AI experiments into production. In fact, Gartner and Deloitte, in this case, these are Deloitte slides, are actually saying around about 20% of all of the organizations around the world are pushing most of their experiments into production. And as you can see, most people are not pushing all of their experiments into production. So only about 26%, some say less, of those experiments are actually being moved into production. So there's definitely a counter-rotating view of large language models. And we can see that all over the press right now. And maybe we should, maybe we shouldn't be quite surprised by this. And we'll get into why that is the case in just a second. So lots of reasons, lots of ideas about why that is actually happening. But let's bring it back to RAG. So we know that we have a number of architectures for RAG. We know that as you go down the RAG architecture, you will kind of increase latency, because down here we're doing a lot more with the data and self-checking and correcting our answers as we go by checking things. We're increasing complexity of the architecture, but we're also increasing the accuracy that we get from simple naive RAG all the way down to agentic or agent-based modular RAG systems from that. And what's interesting is that the O1 LLM is one of the first LLMs that has actually taken some of these principles inside the actual model itself. So the O1 model uses reinforcement learning during training. So it is constantly checking itself to make sure as it's learning, have I learned the right stuff here, or have I made a mistake in my understanding of what that thing is telling me? It breaks problems into steps. And of course, we know that if you break problems into steps, that will increase latency. So most people are saying that the O1's outputs are not, 2 or 3 seconds. They might be up to 30 seconds, but you will get a better answer. It also learns from trial and error. So as feedback comes into the system, it's starting to understand that it can change its behavior based on what it's learned from that. The key thing is, though, that these new large language models potentially can take a lot longer to respond than the incumbent large language models that are out there. If you want to read a little bit more about this, lots of these slides, especially these large language model charts, have come from this website. I really urge you, if you don't know about it already, just go there. This guy is really hot on keeping up to date with all of the latest changes that are going on within the large language model space. I did a quick analysis of the descriptions of these RAG techniques, when to use it and what the simple definition of each of these are. And as you kind of go down this list, you see that it's worrying about complexity, it's worrying about high accuracy, it's worrying about implementing architectures that don't currently work well with non-architectures, if that makes sense. So things earlier up this chain, and it's all about increasing accuracy. And we'll get into that in a lot more depth in just a second. But I wanted to pose a couple of questions to you. So you might see these kinds of questions in your query logs. Essentially, what's the price range of a good quality coffee machine? What was the total spend on our AI projects last year? What's the best air fryer? What's the average trade tariff between the UK and Japan for the last 10 years? What's the latest news on SpaceX? What documents did Phil Lewis create on RAG last year? And on the surface of it, these are all questions that you would think RAG would have an easy time answering, but they're actually pretty difficult. And the difficulty comes from these pieces of information. We've already seen that large language models can't reliably add up numbers. So when you say what is the price range of an object, you're kind of opening yourself up to potential problems. And it will give you an answer, right? But it might not be the right answer. And you need to know when it's not giving you the right answer. So you need to start thinking about some way to measure. And that's the thrust of Matt's conversation in just a second. But also, this is a problem too. Good quality. How does the system know what a good quality coffee machine is, right? Do you have a rating system? Is the ratings data in with the product catalog for the product itself? Or is it in a reviews list, which is a totally separate list? It's not in with the product specs. What is the total spend? What is the best air fryer? Whenever you see these words, who's making the decision on what is best? What is average? What is the latest? What does last year mean? You'd be surprised that a lot of large language models don't even know what the date is today. Most do, but some don't. Okay, and this is a really interesting thing to worry about going forward. And I think this is one of the main reasons why this uptake of Gen AI and LLMs in general may be stalling a little bit, because they're kind of giving unexpected responses. Really, my last slide before handing over to Matt is really about the value, the business value that you can get from these types of applications. Generally speaking, is it on balance better to have RAG-based systems or not? And how do these things add up? Okay, so there's definitely tangible benefits to users to be able to have these RAG-based systems wherever you are on that kind of RAG maturity, whether you're right all the way up at the naive level, or whether you're all the way down, maybe using graph RAG for some types of interactions with users, or other types of RAG. And finally, it really does move search on after 50 years of stagnation. Search boxes and search interfaces have really looked the same for the last 50 years. And I should know, I've been in the search industry for 30 of those 50 years, and it really hasn't changed much at all in that time until the last few years or so. And it's really starting to produce ground capabilities. But you need to know what it can do well and what it can't do well. Okay, so that's difficult. The only way you can do that is by measuring, optimizing, measuring, and optimizing again. And of course, there is a little bit of disappointment because we're starting to find out as a group of industry specialists and industry visionaries that it's not as simple to implement for all use cases, as we've already seen by that long chain of RAG-based models. Some queries will be better answered by RAG models higher up the chain. Some types of queries might be better answered by maybe GraphRag or some other slightly more complex thing. And that's where the difficulty comes into. One size doesn't fit all. My key thoughts really are keep the faith. The plateau of productivity is coming. Lots of these problems that we're seeing today will be solved. They will either be solved by very definitive, easy to understand architectures and products that can cope with that. And we, behind the scenes, are building a product to accommodate all of these different types of capabilities. It's the Pureinsights Discovery Platform. I'm not here to talk about that, but it is something that people are working on already. But you also should know what works well in your organization. And Matt will talk about business rules in just a second. Sometimes we need to put business rules in place to help the RAG architectures just do the right thing within your system. It might be obvious to you that when you say a certain type of question, you meant that data source on the left, but the RAG model might find data which is totally cosine similarity linked, but not necessarily the best data in order to answer that question in the right or the right-hand side data set. And if you know what works well, and that becomes very visible to everybody involved, then you can have a plan for what doesn't work well. Okay? And that's the key thing that Matt is going to talk about in just a second. All about measure, 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 optimize, optimize, optimize to help progress your RAG-based applications, which absolutely are still proving to be some of the most innovative software applications out there today. Okay, so with that, I'm just going to hand back to Graham, and Graham will introduce that.
Thank you very much, Phil. So Phil's going to be back on the stage in 20 minutes or so for the Q&A session. So you'll be hearing probably some more from him then. But yeah, with that, let me hand over to Matt to talk about the second part.
Let me share my screen. 1 second.
Yeah, can see that, Matt.
So I'm going to talk about optimizing RAG systems, which, as Phil's already highlighted, is largely down to measuring and understanding what's going on with your data. To do it, I'll show you a number of AI-generated pictures, which will illustrate that the problem of getting things exactly right is not just limited to LLMs. Sometimes image generation can be a bit tricky too. But first, I wanted to tell you a quick story that we've heard over and over again over the last year or so. So imagine you're working as a product manager at a publishing company, and it's November 2022, and ChatGPT suddenly explodes onto the world, and suddenly there's a huge burst of excitement. They jumped to 3 million users in only 3 days, and there's a huge explosion of interest. This percolates up to your board of directors, and the board starts to ask, what are we doing about AI with our company data? And gradually that trickles down as a question and lands in your lap, plop, and you think, what are we doing about AI and ChatGPT and our data? So you start to look around, do some research, and you discover that a lot of other people are asking the same question. And a new approach is arriving on the scene called RAG, which I won't explain. Phil has covered quite comprehensively. So you explain it to your board, and they say, excellent, off you go. We need to make sure that we're not behind the curve and we maintain competitive advantage, all that sort of thing. So you create your RAG project. Off you go, you start to index some data, you grab an LLM and you start to play around with it, you optimize it a little bit, and then you put it in front of a few people, and you find that some of the answers that are coming back are not quite how you would have expected. In fact, some of them are downright wrong. I generated this GPT in about 5 minutes, which just shows it's easy to get ones that make very bad answers very quickly, but getting good answers back takes a bit more time. You put it in front of your users, and they start to realize that actually this RAG stuff is harder than anticipated. It's not all just magic, especially when you want it to work in the way that you need it to work for your business. And actually there's some more work to be done. So you put it in front of the board, who are now not so happy. In fact, there's steam coming out of their ears, and they ask you to put your thinking cap on and figure out what we need to do to make this system better. So you decide to take a scientific approach, and following the old adage, if you can't measure it, you can't improve it. You decide to take an approach that will allow you to measure, make changes, measure, make changes, and gradually, incrementally improve it. And that's kind of where we find a lot of people right now. So I'm going to go through some of the things that we think are good to measure, explain what they are, why to do them, and also then cover off some of the things that you might want to change in order to improve your RAG system and to evaluate the improvements that come from that. So there's 4 different areas where I've grouped these. There's the retrieval, which is the R bit. How good are we doing at grounding the answer in our data? There's the G bit of RAG. How well are we doing at generating a good answer? There's a little detour into summarization, which is an important kind of use case for RAG. How well are we summarizing a topic? Are we covering all of the key bits of information? And then there's the more holistic sort of measures. How useful is this anyway? Are we really adding business value? Are people enjoying it? Can we demonstrate the business driver and value behind doing all of this? So jumping straight into those, for retrieval, this should be familiar for a sort of special interest search group. There's some well-known and well understood retrieval metrics. We've got precision, recall, and the F-score at the top. Precision measures, how many of the contexts would be considered good or relevant that are retrieved. So what proportion of them will be considered good. Then recall is what proportion of all of the ones that we could put in front of the LLM we're managing to retrieve. And F-score is a kind of a combination of those two. And then we're also interested in rankings metrics. So there's NDCG, which looks at the overall result set and the ranking and compares it to a kind of a gold standard for ranked results. That's quite labor intensive to put together. A more simple one is mean reciprocal rank, which is essentially an average of the ranking of the first relevant document returned from the retrieval system. So I'm not going to spend much time on that. These are well-known metrics, and they apply here. That's the point I want to make, really, is that we've got retrieval in RAG. We need to use the levers and the metrics that we already know about to understand how well we're doing with retrieval. Less well-known and also changing quite rapidly is metrics we might use to understand generation. Now, it's a bit of a mixed bag because everyone's calling them slightly different things at the moment. So I've tried to summarize these into the areas where I see people taking measurements and trying to measure how good the generation is. Now, the first one would be faithfulness or hallucination. So that's if we put a set of data in front of a large language model, is it accurately representing the data from our company that we've told it to use, or is it producing hallucinations? So that's a really critical one. Generally, the LLMs these days are pretty good, but they can be a bit strange with things like, as Phil said, ranges and dates and relative values. Then there's accuracy. All right, we might have not hallucinated and been faithful, but is it actually the right answer to the question posed? So if our retrieval is not good, we may not get an accurate answer. We may not get the correct answer that people are expecting. Then we've got entity recall. That's given the target response that we're interested in, how many of the entities that are mentioned in that are we getting back? So how good is a summary and how thorough an answer are we providing? Then we've got similarity. That looks at, given our target answer, using regular kind of NLP techniques, how similar are they? So it's another way of looking at how good are we matching up to our target response. And then finally, there's one, knowledge retention, which is applicable when you've got a chatbot or a conversational interface, and looks much more at how much of the history is the system retaining in order to make sure it's keeping track of what you're interested in, what you're trying to achieve. So those are the 5 kind of areas of metrics that we might consider for generation. We can then also move on to summarization metrics. If you are doing summary, it's also important to look at how much of the information that we would want to appear in an ideal summary gets presented back to the end user, or gets turned into a summary. Does it contain all of the key pieces of information that need to be summarized? And then the compression ratio. Sometimes we might be targeting a particular size of summary, let's say 150 words, or we might be looking to summarize something down to 50% of its original. So we need to measure that and just understand whether the LLM is doing a good job of providing a concise but thorough answer. Then finally, the 4th category is the more holistic ones. These are more difficult to measure. We see everybody doing a human evaluation. Human judges assessing the quality of the retrieval. They're looking at the relevance of the answer. Is it coherent? Is it fluent? How informative is it? And normally we'll have a feedback mechanism to allow people to just provide cues so that we can improve. But then there's also, and shouldn't be forgotten, end-to-end task success. Now, does this actually allow people to accomplish the tasks more quickly, more accurately, and to be more productive? That's absolutely critical. That's the key thing that the business is asking us to provide the tools to do. And so we shouldn't lose sight of that when we're focusing on the more technical side of things. Third one is user satisfaction. I'm differentiating that from human evaluation. It could be that you get some incoherent results, but actually people really love using the thing, and they come back again and again. They ask lots of questions. They really interact with it and find that it's making their work life not only more productive but more enjoyable, and with less friction, I suppose. And then the last couple sort of more holistic ones are, we need to keep an eye on things like, are the responses safe? Is it possible for somebody to game the system and get access to some information we didn't want to provide them? Is it adequately concise? Is it biased? Those are the sorts of things that we often see. Particular customers might have different concerns that they need to be sure. One of them is being confident that the system works so that people trust it and do continue to use it. And then lastly, there's latency. As Phil highlighted, as these sort of strategies for doing RAG get more and more sophisticated, they might take a multi-step approach where you have maybe several passes at getting some information and then assembling it and summarizing it. That can take more time, and so it has more of an impact on latency. I've been playing around with the O1 model recently, and I managed to get it to think for 60 seconds. I thought I'd broken it. So it can take a while to generate a response if you're doing something that's a bit more sophisticated. So before you run away in terror at all these different metrics, I should highlight that in parallel, there's a bunch of frameworks that have popped up to help you do that. I'm not going to cover all of these. I'll just call out a couple of them. There's Deep Eval, which I like the look of best, but haven't had a chance to use yet, which seems to have a very comprehensive set of metrics, as well as tools for managing your test data sets, a nice user interface for feedback and all that sort of stuff. It operates on a sort of a freemium model where you can get extra stuff by paying a bit of money. It also wraps up the second one, RAGAS, which I'm going to talk you through in a second, which is the most kind of commonly seen one. And then a couple of others, Uptrain and TrueLens, are also nice looking platforms for you're providing a benchmark for doing this kind of measurement and evaluation. Those tools have sprung up relatively recently, and I expect them to get more mature over time. So keep an eye on them. But you can get going pretty quick. If you've got if you've got developers, you can get going very quickly, as I'm just about to show you. And this allows you to just test out different ways and permutations of configuring your RAG system. So then I'll run through some of the options that you might consider as you kind of gradually improve things. So here's an example. We're going to compare two LLMs, Falcon 7B and Zephyr 7B. So they're two open source engines. So this is comparing how well they do at generating data. But for that, we first need to have a set of data in order to evaluate. And happily, these tools make that very easy for you. So if I have a document set, in this case, it's a set of data to do with information retrieval, as well as a few others and pieces. I can, in 3 lines of code, you don't need to worry about the code here. I'm just trying to show that it is only 3 lines of code. But you pass in your documents, you tell me, generate a test set with 5, in this case, items in it to keep it simple. And we can very quickly get back a test set of data with a question, a context, and an answer. So that's the 3 things we need in order to be able to generate some of the metrics that I talked about earlier. We can then do that at scale. I would normally recommend that you maybe generate 500 questions, or minimally 100, and then review the auto-generated test data to make sure that you're happy with it, because obviously we know our data better than a kind of tool like this. But this gets you moving very quickly, and then you can start to do the evaluations that I've spoken about. So very easy to get going with. Second step is to set up the metrics and run the evaluation. So we can do that very quickly in this tool. It's got, as I've said, it's got maybe 10 different metrics baked into it. We're interested in the ones to do with the generation side, because we're evaluating the 2 LLMs and how well they do. So the first one is faithfulness, which I mentioned before. How justified is the answer based on the context that we've given it? Answer relevancy, that's to do with how good is the answer. So it might give you an answer, but is it covering all the things that we would want from an answer? So if I asked you who is Donald Trump, and the answer comes back an orange golfer, then that's not covering all the things we'd expect that answer to cover. And then answer correctness is it actually accurate? It needs to be measured against reality to make sure we're getting a correct response back. So having set those up, you can very quickly test that against your current set of configuration. So in this example, Query Engine 1 here, it represents the set of configuration with the Falcon LLM, and then there's a Query Engine 2, which not shown, which is the other LLM, the Zephyr LLM. But within that sort of query engine, we could have different prompts, we could have different filters, we could have whatever we're happening to test at the time. We just passed in our test questions and our answers against our config, we generate the responses, and then we ask it to evaluate against the metrics which we've said we're interested in, and you get out down the bottom here a set of scores that tell you which one is doing better. We've got faithfulness, relevancy, and correctness there. They're measured on a score of 0 to 1, with 1 being better. And then we're immediately into a situation where we know what we're doing, or at least we understand the outcome of our experiment. So we can see from these graphs that, which one is that? Falcon is doing better on relevancy. They're much the same on faithfulness. And Falcon again is doing slightly better on correctness. So now, all of a sudden, with only a few lines of code, we're in a situation where we can start to test and evaluate how well different ways of setting things up perform. And this is very powerful, of course. So, but then you run into the next question, which is, well, okay, now we know how to do it. What should we experiment? What should we change? What variables do we want to tweak? And I think the answer to that is formulating an approach, trying to understand, changing one thing, trying to understand the differences, and then creating a hypothesis and creating a next experiment to try and answer that question and iterate from that. It doesn't need to be a very, very extensive, long process, but it does need to have some analysis, some understanding of the data and where the gaps are. And so then we start to move along the line that Phil highlighted, where we're going from a basic RAG to a much more sophisticated one. And the sorts of things that we can change are, as I've said, we can choose a different LLM. That's one thing. We can incorporate hybrid search. So maybe we have a vector search paired with a keyword search, and we blend the results to do what we call a hybrid search. Maybe that takes the best of both of them. We see a lot of clients doing that. We can do what Phil calls metadata stuffing. That's where you take the chunk of text that you want the LLM to answer from, and you shove in some data about maybe topics and dates, and maybe the title of the article, to help the LLM understand the context that the snippet of text comes from, or any other useful metadata. Freshness is a really important one. We don't want to get the answer from a report 10 years ago, which is outdated and has been replaced by this year's report. So we need to be conscious of and sort by often the date if you've got competing answers. Then if we've got hybrid search, we need to do things like traditional relevance tuning, making sure that field weights and things like synonyms work well. Phil already highlighted this. Business rules is quite an important one. We're seeing that quite a lot. One of our clients, one of their data sources is trade tariffs between different countries. Now, we don't want to go to an article discussing trade tariffs to get an answer there. We want to go to their database that has the actual data about trade tariffs between different countries there. So we need to have a business rule that allows us to focus in a particular area and that knows about these data sets, especially if you've got competing or multiple different data sets. Prompt engineering, the way that you word your prompt. Phil gives the example that if you just put the word excellent in front of "you are an excellent chatbot," it gets better. You wouldn't think so, but it does. So the wording of the prompt is extremely important. Prompt selection. If you may have different prompts for different data sources or different types of queries, and you can have like an Uber prompt that chooses the one you want to use, and then build out from there. Chunking strategy. If we chop up our data in a different way, that will have a big impact on the way that the LLM is able to select and formulate an answer. And then there's a couple of more exotic ones. Question reformulation, also called RAG fusion, I've seen it called, which is essentially where you ask the LLM to take an incoming question, generate multiple different variations of it, and then fire those off, and then recombine the results so that the context that appear in multiple responses are likely to be better. And that deals with the point where maybe a question is a bit ambiguous, so you can get over that by sort of exploding a question into multiple other questions. And the opposite of that is as you index the data, you can enrich your data, say, for this chunk, what questions might I be able to answer? And then you search the questions instead of searching the chunk. And then last but not least, graph contextualization, which is becoming more of a thing. We have a GraphDB in our platform, but historically it's been quite difficult to build a knowledge graph. There's now a lot more tools coming available to allow you to build a graph-based representation of your data that allows you to leverage that to provide something similar to business rules. So there's a whole bunch of stuff that you can do, and none of them is a silver bullet, but some of them will be important to get right early, such as LLM selection, freshness boosting, prompt engineering, and metadata stuffing. Those are the key ones that we're often recommending most commonly. And with any luck, having done all of that, you've suddenly got a happy board finally, and you've got a good foundation with an automated set of tests that allows you to onboard more new data sets and continue to improve over time. So key takeaways just very quickly. Effective RAG requires careful measurement of retrieval and generation. It's important to consider the bigger, more holistic factors like efficiency, satisfaction. Different tools and techniques will help in different contexts. So you need to analyze and choose according to use case. And then kind of plan to need to evaluate frequently and over time to keep the thing working and to ensure that as new data is incorporated, things don't degrade. So that's the end of my presentation. So I'm going to hand back to Phil for the Q&A session.
Guys, I don't know if you've got any sort of finishing comments, Graham?
Yeah, other than to say, look, thanks very much for joining, everyone. Hope you found that interesting.